Hello friends and welcome to the tutorial of PIC18F4520 controller and programming using C18 compiler part 1. In this tutorial we will learn the basics of 4520. I know myself that the basics of any controller are quite boring and we all just try to skip all this and directly shift to the programming section of that controllers. But believe me friends, programming without knowing the basic concepts of the controller is of no use and we can't reach up to the mark in programming. So in order to reduce some boredom, I have tried to sum up the things and present you the only required info for programming. So let's get started. So the very first part is introduction, where we see the basic family of PIC controllers. As shown, PIC is divided into three subcategories, that is 8-bit, 16-bit and 32-bit. These categories represents the generalized processing capabilities of the controllers. 8-bit represents the controllers that can process 8 bits at a time. Likely, 16-bit represents the controllers which can process 16 bits at a time, and 32-bit category can process 32 bits at a time. Depending upon the different capabilities and list of functions an IC can perform, these categories are again divided into subcategories. PIC10, 12, 16 and 18 all come under the 8-bit categories. That is, all these ICs will process 8-bit data at a time, but all have the advanced functioning than the others. We are dealing with the PIC18F, which has the highest functionality under the 8-bit category. Similarly, PIC24F, 24H and DS-PIC30 comes under the 16-bit category and PIC32 comes under the 32-bit category. 64-bit controllers have also been developed in the era, but not much implemented yet instead of some Windows Phone 64-bit processor by ARM chips. Here comes some of the basic features of 4520. Firstly, it has a flash memory of 32K. Flash memory is that temporary storage of the data which is kept at the time of power failure so that it could be retained. Likewise, we have the auto savings in our office files if we directly close it. Secondly, it works upon the RISC structure, where RISC stands for Reduced Instruction Set Computer. That is, while programming PIC, we don't have to retain or learn a much long series of instructions and registers. Next, it has an operating speed of 40 MHz, which is quite enough for an 8-bit controller. It also supports up to 256 bytes of EEPROM data memory. That is, external memory could also be accessed for the higher command operations. It also has a watchdog timer and fail-safe clock monitor. Thus, it can prevent the IC from hanging in any of the case. Talking about its ports, 4520 has 5 ports from port A to E, while port A to D are of 8 bits each and port E is of 4 bits to directly handle the nibble operations. Now coming to the peripherals of 4520, first of all it has 4 timers from timer 0 to 3. It has a serial port for serial communication, but eventually in synchronous mode only, though the communication is possible through both SPI and I2C. It also has built-in UART, that is universal synchronous and asynchronous receiver and transmitter. It has two capture compare PWM mode. Capture mode is used for recording up some sort of the bits and then operating upon them. Compare modes are used for comparing two signals, and PWM is the pulse width modulation. In addition, it has a parallel slave port, 10-bit analog to digital converter, and has an operating voltage range from 2 to 5.5 volts, which means you don't have to worry about the minor errors in supply voltage. Talking about the architectures, we all might be knowing, but those who don't, there are two types of architectures. One is von Neumann architecture and the another one is Harvard architecture. During the war in 1940s, US government asked two persons to develop such a thing, but due to the limitations of the technology at that time, von Neumann's architecture was accepted and implemented. But due to the higher speed needs and large amount of data transferring required, Harvard's architecture is implemented in present era, where data and instructions are carried upon and stored in same memory, which wasn't in the case of von Neumann's. Here, as shown in the diagram, von Neumann's architecture is built upon a single memory handling all the operations of data and instruction storage. Thus, a single bus carries the address as well as the data. So, the time required for the operation to complete becomes much higher, that is, it takes more than one machine cycle for the execution of the instruction. Despite all this, von Neumann's architecture has its own advantages, which were seen at first. These are, it simplifies the design of the microcontroller, and yes, also covers the concept of cost. Now, as per the case of Harvard architecture, it handles the data and instruction memory separately as prescribed in the diagram. So accordingly, it has different buses. Program bus to carry the instructions and data bus to carry the data. Accordingly, it takes only one machine cycle to fetch and execute the instruction, thus implementing the possibility of pipelining concept. Thus, using this architecture gives us the advantages of assessing the greater speed and saves time. Also, a great extent of parallelism is possible. That's the block diagram of 4520. Apparently, it's very complicated and difficult to understand. Reasonably, there is no need of doing so. It's just that we have to examine it once to know how actually the IC is manufactured and working. As per the view, we can see that program memory and data memory being separately accessed by the address bus and data bus accessed through registers, which are further controlled by the control unit. For program memory, address bus is of 21 bits with a combination of 8 plus 8 plus 5 bits, as it is a 8-bit processor, and data bus of 16 bits of combination 8 plus 8. The data memory has address bus of 12 bits with a combination of 8 plus 4 and data bus of 8 bits. As per the ALU, that is arithmetic logic unit, it consists of working register, that is W register, status register, and instruction decoder. W register can be compared to the accumulator of other controllers, and the rest of them performs the same basic function. At last, we can see the ports attachment or implementation, where the ports are shown bidirectional. As we can see, data is latched from the data memory and attached to the addresses, all controlled by the BSR, that is bank select register, FSR, that is file select register, and access bank. So that's all for this video. Hope you learned. For any queries, questions, or suggestions, you can post it or mail it on our provided links.